Cover the initial parts of section 5.5, focusing on two concepts where we can use trigonometry and specifically the sine function to help us out. And that's going to be computing the area of a triangle and also solving a triangle using a principle called the law of sines. Now, if you looked at the formula right here, area of a triangle, A equals 1/2 base times height. It's something you in all likelihood remember. You've seen it probably all the way back into elementary school days, certainly in geometry as well. And it's a general, nice purpose formula for the area of a triangle. And if I had a triangle such as the one I put over here, which happens to be a right triangle, the nice thing about this is what? The base and the height leap right out of us. It's very, very obvious. And so I could say the area of this triangle is nothing more than 1/2 times 6 times 8 and get an answer of 24. And I compute this thing very, very quickly. However, as we're going to find throughout this unit, not every triangle is a right triangle. We could have something that looks like that. Well, again, I can kind of rotate it, and gee, it looks like you wrote something that's a 90-degree angle. And if that was how this was built, I could probably compute that real quickly, even though when I first look at the shape, it looks something like this. But let's do something that I can guarantee you is not going to be a right triangle. So let me draw one more. Start here. And we'll do something of this nature. Certainly not a right triangle here. How can I get the area of this? Well, I can, flip this thing, make it flat however I want to, and kind of call it a base, but I'm always missing the height, what we're kind of used to calling an altitude. So let's do the following. Let's just take a look, and what we're going to see is there's going to be a way that we can compute the area of a triangle using a very simple drawing concept. And let's take a look at it right here. I've drawn another triangle. I'll call it ABC. It kind of looks like an equilateral triangle, but that's purely by happenstance, just how much room I had to draw this and fit it into the particular grid that I wanted to work with. So just treat this as any triangle. Again, it could be like anything written over here, anything like what I'm drawing right there. And the only other thing that I've done is I've kind of, as I did before, I've rotated it so that I can at least see the base. I've labeled this as triangle ABC. I can clearly see what the base is. And by the way, and this is the nice little drawing technique, if I draw a quick little perpendicular, what does that create for me? Well, it creates a right triangle, which is very, very helpful. And then it also gives me what? Well, there is h. Sometimes you may be called that an altitude. But this value of h represents the height of the triangle. 1/2 b times h should give me the area of this triangle. And the question is, well, how can I solve for h? Again, in our cute little right triangle, where I know it's really a right triangle, the height is right in front of my face. It's no issue. But here, how can I do it? Well, it turns out I'm going to focus on this little angle over here, which will be angle C of my triangle. And I can notice the following. Working with the triangle, the right triangle that's on this side that I just have kind of highlighted with my pen, I could say that the sine of angle C is nothing more than what? SOHCAHTOA principles, because this is a right triangle. It's nothing more than opposite over hypotenuse, or h over a. The sine of C equals h over a, which in turn tells me, oops, sorry, let me just move that. Tells me very quickly that what? H is equal to a times the sine of C. And so 1/2 base times height now becomes 1/2 base, what's our new value of h? A sine of C. And we've walked right into perfectly the area of a triangle formula. This will work for any triangle. It certainly works for a right triangle, by the way. Check out what the sine of 90 degree is. You'll see that it's 1. But bottom line, this little technique allows us to solve the area of a triangle. I could have done this over here as well. I could have said 1/2, hey, the sine of A would be equal to h over c. Gee, I could say h equals sine of A times c. It gives me a lot of power. And it turns out that this is a very nice formula. What does it require? I could say the area of the triangle is equal to 1/2 AB times the sine of C. I could say it's equal to 1/2 BC times the sine of A. It's a powerful formula. And what's the key? What do you have? Well, you have two sides and the sine of their included angle. And that's what you see up here. If anytime you are able to solve two sides of a triangle and know the angle that those two sides create, the angle in between or the included angle, you have the formula for the area of a triangle. And we can say here, if I want to, I'm just going to fill in other pieces. 1/2 BC sine of A. 1/2 AC the sine of B. All three of these formulas work. Two sides, included angle, and you're good to go. So let's look at an example very quickly. I have triangle FGH. F is equal to 75 degrees. Little h is 5, G is 4. Well, I'm going to draw something. There's F. Looks like I got pretty close to a 75-degree angle, but there's capital F. I'll put G here. I'll put H there. What's that tell me I need to do? Well, my little h is 5. It better go there. My little g is 4. Better go down here. And there's 75 degrees. What's the area of this triangle? I got two sides in the included angle. 1/2 5 4 times the sine of 75 degrees. Bring it over my calculator. Let's make sure I'm in degrees mode real quick, which I certainly am. 0.5 times 4 times 5, and then I'll do times sine of 75. And I come up with 9.65 or 9.7 square units is what I would have. In this case, it's centimeters squared. So a pretty basic concept. Let's work one more example. Adjacent sides of a parallelogram, as I've drawn here, are 12.5 and 8. Here's my parallelogram. The measure of the included angle is 40 degrees. Find the area of the parallelogram. Now, I'm going to show you a couple ways to solve it, but the key thing is what? Well, hey, we're doing a lot of triangle stuff. Take a look at what I'm going to do. I'm going to draw a diagonal just like this. What do I have? G, a triangle, and I could get the area of this triangle. By the way, these two triangles ought to be similar to each other, so if I can get the area shaded here in red, multiply it by 2, I'm home free. I would have 2, 12.5, 8, 1/2, 12.5, 8, the sine of 40 degrees to get that red triangle. Let's do it. 0.5 times 12.5 times 8 times the sine of 40. Oops, I had divided. 0.5 times 12 times 8.5 times the sine of 40. Excuse me for my calculator typo there. 32.7. Let's take a look again if we like. 12.5 and 8 times 1/2. Oh, lots of calculator errors today. One more time. How about 12.5 and 8? 0.5 times 12.5 times 8. I like that so far. That's much better. Times the sine of 40 degrees. 32.1. And I could double this, and the total area would be 2 times 32.1 equals 64.2. That would be the area of this parallelogram. Now, one other thing to note, this angle over here, if I hadn't split my triangle this way, let me just draw it one more time. 12.5, 8, 12.5, 8. This angle here was 40 degrees. This angle over here happens to be 140 degrees. Remember, parallelogram, those two inside angles better add up to 180 degrees. I could draw my triangle like that. What would I have this time? I'd have 2 times 12.5 times 8 times the sine of 140. Let's see if I can do it right in the calculator this time. 0.5 times 12.5 times 8 times the sine of 140. I got that exact 32.1 answer just like I did when I worked with the triangles this way, the diagonal the other way. And why is that true? Well, here's why. Because the sine of 140 degrees is equal to the sine of 40 degrees. Reference angle, 40 degrees for both. Who has a reference angle of 40 degrees in quadrant 2? 180 minus 40, 140 degrees has 40 degrees as its reference angle. And what do you know? In quadrant 1 and quadrant 2, the sine function is always positive. So there we are with area of a triangle. We'll go ahead and stop this video, and then we're going to roll into the law of sines next.